We're going to go straight to examples on this, and we're going to look at given we're going to look at some information about a right triangle. We're going to draw that, and then we're going to find some trig ratios for it. So it should be fairly simple once we get used to the instructions. So for triangle ABC, angle C is the right angle. Find cosine of A if B equals 4, C equals 4 root 17. Alright, so the first thing that I'm going to do is draw a triangle, a right triangle. And after that, I want to label my angles. So I'm just going to pick A, B, C. Remember, C is always going to be the right angle. That's what it's saying there. So maybe this will be B and this will be A. And I'm trying to figure out what cosine of A is. So this is the angle that I'm focusing on. That means this is the opposite side. That's the adjacent side. That's always going to be the hypotenuse. Alright, so we can continue. B is 4. So the angle B, that's talking about the angle, but lowercase b refers to the side length B. The side length of B. So this is going to be 4 because for the convention of right triangles, you name the angle opposite the whatever the side is called. And then C, that's the hypotenuse, 4 square root of 17. And we want to find cosine of A. Well, cosine of A, that's, remember, if you remember SOHCAHTOA, that would be the ka part for cosine. That would be adjacent over hypotenuse. So if we're focusing on angle A, the adjacent side would be 4. So cosine of A would be the adjacent, 4, over the hypotenuse, 4 square root of 17. Those would cancel out, so you'd have cosine of A equals 1 over the square root of 17. And I'm going to do what's called rationalizing the denominator. You don't have to. This is an acceptable answer right there. But for most textbooks, they will rationalize the denominator, which means they'll multiply by the irrational part, which is the square root of 17. And they'll do that in the top and the bottom. So then we get cosine of A equals the square root of 17 over, and then the square root of 17 times the square root of 17 is just 17. This and that are both the same thing. They just look different. So there you go. I'll do another one. It's pretty easy. But first, let me reiterate the steps. So what are we doing first? It said for triangle ABC, C is the right angle. Find cosine of A if B is that and C is that. All right. First thing I did was I drew my triangle. And I labeled all the angles. And that told me, so if this was angle B, then this was going to be the side B. If this is angle A, then this is going to be side A. If this is C, then the hypotenuse is going to be C. So that's how I labeled that. And then they tell me the side lengths for some of the things. And I don't actually need the opposite because I'm looking for cosine of A. Cosine of A using SOHCAHTOA said that I had to take the ratio of the adjacent side and the hypotenuse, so adjacent over hypotenuse. This would be the opposite of angle A. So we have adjacent over hypotenuse, and then I simplified. Here is where I rationalized the denominator. That means you just multiply by the irrational part, the square root of 17, in the bottom and in the top. And then I got that, and that is all. Similar instructions, find sine of A if B equals 24 and C equals 25. So remember, my first step is to draw my triangle, my right triangle. It said that C is always going to be the right angle, so that means that's going to be length C. So that will be 25, because it's always going to be opposite that angle. And then I'm just going to pick. I'm going to choose this to be A again, and that to be B for the angles. So that means if I have 24 for the side length of B, that's that side. So this would be 24, and I don't know what side A is. Maybe I won't need it. So the sine of A, that's what I'm looking for, sine of A. Well, if we use SOHCAHTOA again, sine, so, that would be opposite over hypotenuse. So what is the opposite of this angle? That's side BC, which is side A. I just named it because of those vertices. But so I actually do need this part, and then I have the hypotenuse already. So, so what I do now, well, I take this and I can use Pythagorean theorem, or I think this is a special right triangle, but I'm going to use Pythagorean theorem anyway. So this was B, and we could say A and C. So I do A squared plus B squared equals C squared, and solve for A squared plus 24 squared equals 25 squared. So if I square 24, I get 576. And I square 25, and I get 625. And I will subtract 576 from both sides. And then I'll square root it. So I have a squared equals 49. And if I square root both sides, I'm going to take just the positive version. A equals 7. So there we go. A is 7, and I'm ready to finish my problem. It's very easy now, because I'm trying to find sine of A. Remember, I'm trying to find the sine of that, which is the trig ratio of this triangle. So, what do? I just take this. I say sine of angle A. That's going to equal the opposite side, which is 7, divided by the hypotenuse, and 25. And there you go, and I can't reduce, so that's it. And then bada bing bada boom, which is easy as pie. Pie is kind of, the crust is kind of difficult to get right, but I'm going to leave now.